Hi, and welcome to Module 3 of this pluralsight course titled Practical MVVM. My name is Gilles Kleren and you can contact me on Twitter via @GillesKleren. In the previous module, that is Module 2, we have laid the foundation for our MVVM knowledge. We have covered what WPF offers in terms of data binding. Understanding data binding is vital for the core concept you'll learn in this course, and that is MVVM, aka the Model View Model pattern. In this module, you will learn the core concepts about the pattern and how to refactor an existing application which is built without MVVM so it uses the pattern as well. Let's start by exploring the agenda for this module. As mentioned, this module is all about MVVM, and we will kick off the module by learning what MVVM is, what it does, and how it can help us writing XAML applications which are easier to test and maintain. MVVM is a letter word, and the 4 letters in the word all stand for one of the core building blocks of MVVM. And in the second part of this module, we will explore this in some more detail. Finally, after we have learned about the view and the view model, we will need to have these two connect with each other. There are several ways of doing this, and we will in this topic explore one of the most common ways of linking these two. By the end of this module, you will have a solid understanding of the MVVM pattern and what is the function of the different building blocks it's composed of. Also, by the end of the module, you'll have gathered some arguments on why it's a good idea to start your next XAML application based on the MVVM pattern. Now that we know where we are heading in this module, let's learn about the MVVM pattern. That is, after all, what we are all here for. MVVM, aka the Model View Model pattern, is in itself nothing more than a software or architectural pattern. It's in fact a variation of the MVC pattern and thus can be seen as a variation of the presentation model which has been around for many years already. Just like the presentation model, as well as MVC, MVVM has as its most important goal a better separation of concerns. MVVM is relying heavily on what XAML has to offer us. Without data binding, MVVM wouldn't be able to work like it does. MVVM is therefore a pattern which is very often used in XAML-based application and works similarly in WPF, Silverlight, Windows Phone, Windows 8, Windows 10, and so on. Remember we said in the previous module that data binding is the enabler for MVVM. We'll see soon how that is the case here. As mentioned, one of, if not the most important goal of MVVM is creating a clean separation between the different aspects of our code. Typically, we can identify a number of, let's call them, layers in any XAML application. On the left, we have the view code, which determines how the UI will look. The view is typically the area where the designer does his work. On the right, we have the functionality of our application, which will live in the view model. Here we are writing C# code, and it's thus part of what the developer will be working on. The view model will interact with the model or the data. Again, this is part of what the developer will be working on as well. In an ideal world, we would have the ability to give all the UI work to a designer and all the coding work to a developer. We don't live in an ideal world, sadly, and therefore this doesn't always work. However, using MVVM will give us a better separation of the different layers, and so even if you are the only person working on the application, you'll still find a lot of benefit in using MVVM. If we aren't using the MVVM pattern, how are we structuring our code? Let's take a look. So on the left here we have the view. Typically, this view code consists out of some XAML code, which can live in, for example, mypage.xaml. This is purely the UI code which contains no functionality. The functionality can be found in the code behind, so for example, in the mypage.xaml.cs. In this code behind, we often have quite a lot of code, including event handlers, which will react to interactions of the user with the view. Very often too, this code interacts directly with the model. Perhaps we want to get some data from a service, so directly from the code behind, we will be interacting with this service. And when data is retrieved, we want to update the UI again. The problem that arises with this code behind based approach is that everything is very tightly coupled. On one line, we are connecting with the service, and on the next one, we are updating the UI. It's very hard, if not impossible, to test any code in isolation by writing a unit test. The main culprit is that we are directly using our UI controls from code. There has to be a better way. If we now move into using MVVM, things will be quite different. Of course, we will still have a view block, and inside the view, we still have SAML code, which makes up the visual part of the code. Some things may be different here, but the XAML will still be roughly the same. We'll still have code behind as well. Notice that the code behind log is now a lot smaller compared to what we had in the previous slide. This is intentional. There will be very little code in the code behind. In fact, there shouldn't be any code in there which directly interacts with the model. So any code that we may want to test using, for example, unit test shouldn't be in the code behind. However, code which does view-specific tasks, such as setting the focus, will still live in the code behind. The bulk of the code will now be living in the view model. The view model can be seen as an abstraction of the view. The view will have a view model associated with it. Typically, this is a one-on-one relationship. Through data binding, the view will be binding on properties exposed on the view model. And because of notifications being sent by the view model, changes in the value of the view model properties will result in the view being updated. This is courtesy of the iNotifyPropertyChanged interface, which we have already discussed in the previous module. Notice that there's no longer a tight link between the view and the model. It will be the view model which does the communication with the model. So effectively, the view model will, for example, ask the model to load data from a web service. And when this data has been retrieved, it can notify the view model about this. The view model in turn can then do things with the data and then raise a notification so that the view can pick up on this. In the view model code, therefore, we shouldn't have any control references. All communication happens through data binding. This means that we have loose coupling between different building blocks, and that is of course a good thing. Do remember that the view model is exposing properties. Properties can be seen as the state of the view model. The view model will also expose operations in the form of commands, but we'll take a look at commands in much more detail in the next module. So what are the main benefits that we get when using MVVM? It should be clear by now that writing code using the MVVM pattern results in better separation of concerns. The view will be just about the view, so the XAML code and perhaps some UI logic such as setting the focus. The view model can be seen as the controller of the whole setup. It contains the logic of the application. There is no hard link anymore between the view and the view model. What this leaves us with is that our code will be much more testable. It will be possible to write unit tests on the code in the view models. There are typically no UI control references in your view model, which is what you need in order to be able to write those unit tests easily. We'll learn about unit testing the view models in the last module of this course. The code that we write will also be easier to maintain. Since there's no tight coupling between the layers anymore, we can make changes, for example, to the UI without requiring any changes to be made to the view model. Also, when the view model needs changing, it is not required to change the view. Of course, there are some disadvantages to writing your code based on the MVVM pattern as well. In general, you will be writing more code when using the MVVM pattern. One of the main reasons for this is of course that MVVM isn't supported out of the box. By default, when you install Visual Studio, there are no templates available that use MVVM. There are several frameworks available, however, which can get you on your way when using MVVM. Now, the two facts above can direct you into thinking that using MVVM isn't feasible for all types of projects. Mainly for small projects, using MVVM can be a bit of an overhead. Personally, having used MVVM for many projects, I find it to be useful even for smaller projects. You never know how large an initially small project might become in the future, and a refactoring will be much more work at that time. Now that we know what the MVVM pattern is and why we should or shouldn't be using it, let's take a look at the different building blocks in a bit more detail, together with some sample code for each. As mentioned, the view is the user interface and it contains mainly XAML code. Typically, this will be a window, a page, or user control. This is depending a bit on the XAML technology that you are using. The view is pretty simple, definitely when we look at the code behind. This file, so the XAML.cs file, is pretty empty. It shouldn't contain any business logic. The only code we have in here is the code which does things with the UI. Setting focus, ordering columns, changing colors are typical things that we can execute from the code behind the file. Although in some cases they might involve working with the data, there shouldn't be any business logic. So code which goes to the model. On this slide here, we see a sample view, and in the sample view, we have a window which contains a couple of labels. For each of the labels, the content property is being data bound to a property of the selected coffee property. And selected coffee is a property on our view models. So what we're doing here is data binding to properties on objects we expose on the view model. So we are already leveraging the data binding features of XAML. The view model is our next building block, and it's probably in the entire MVVM concept the most important one. As you've already learned, the view model sits between the view and the view model. It's the glue between these two layers. The view model exposes state under the form of properties for the view to bind on. Also, the view exposes operations. In a non-MVVM scenario, we would have event handlers to handle the interactions from the user. In an MVVM scenario, these will channel through to the view model and will be handled using commands we can create on the view model. We'll talk about commands in the next module. Since we are creating the view model as an abstraction for the view, the resulting view model code is testable. It's possible to write unit tests since we can isolate functionality and will have the ability to mock dependencies. I've mentioned this already, but this last one is a crucial one. In order to keep things testable, there shouldn't be any UI elements or references in the view model code. Remember that one of the main goals of using MVVM is writing testable code, and having UI references in code which needs to be unit tested is difficult. So keep an eye out for this one. On this slide here we see a sample view model. A view model is nothing more than a class which implements the iNotify property changed interface. Like I said, a view model exposes state and operations. And in this case, we only see some state being exposed, and that is the coffee's property. The final building block is the model. The model is often exposed to the view model as a data service, which interacts with a repository. The repository in turn perhaps connects with a database or downloads data from a web service. For this, our model is using the object model, and it is returning model instances to the view model. In fact, the model in an MVVM scenario isn't very different from the model in a non-MVVM scenario. One final thing before we go to the demo, a little bit of who knows who in MVVM. I've already mentioned quite a few times that MVVM will help us with separation of concerns and that the resulting code is much more loosely coupled. However, the different building blocks in MVVM at some point need to know each other. That brings us to the question of who knows who. The view, as we have seen, needs to bind on the view model. So the view needs a reference to the view model, that's for sure. Once it has this reference, it will use data binding to bind on that view model. Using data binding doesn't create tight coupling, so we are good here. The view model in turn doesn't need to know the view. It exposes properties for the view to bind on, but it should therefore not have a reference to the view. However, the view model needs to have a reference to the model. This way it can ask the model to load in data and return this data when it is ready loading. In the opposite way, the model doesn't need to know the view model. To keep things loosely coupled, we can, for example, raise an event when the data is ready to be consumed from the view model. This way we avoid creating a reference from the view model in the model. You've learned now quite a lot already. It is now time to take a look at the demo again and see how we can refactor the application to start using MVVM. In this demo, we are now going to refactor our application to use MVVM. The first thing I'm going to do is I'm going to create a new folder in my solution where I'm going to place my view models. I'm going to call this folder View Model. And like I said, view models are just plain classes. So let's start by adding a new class. And I'm going to start by creating the view model for the overview page. The naming convention I personally use is the name of the view concatenated with the word view model. So in this case, that would be coffee overview view model. This view model is a public class which implements an interface, and that would be the iNotifyPropertyChanged interface again. I'm going to implement this interface now, and that results in this event being added. Now, to make things a bit easier, I'm again going to add my rasePropertyChanged method, which calls the PropertyChanged event if someone is listening. And this will be used again for my properties. So this is the overview page. So what do I actually need? The list of coffees. And that will again be an observable collection. So I have a private instance of that observable collection coffees and a public observable collection coffees, which will raise the property changed when coffees changes. Now I need to load data into this observable collection. So what I'm going to do is I'm going to create my constructor. And inside of this constructor, I'm going to call a method, and let's call that load data. I haven't implemented this method yet, so I'm going to have Visual Studio generate it for me. So here's my load data now. Now what I'm going to do in this load data, I'm going to call onto the coffee data service to return me the list of all coffees. So I'm going to create a coffee data service instance here. There you go. And now in my load data, I can use it to load in the coffees. So all coffees are going to go into my coffees observable collection, so the property. And so I'm going to ask the coffee data service to do a get all coffees. That returns a list. So we are going to use the to observable collection again. That extension method we created earlier. That was created in the list extensions. So I of course also need to add this using statement here at the top. So we now have a small view model ready. I'm going to go to my view now, and I'm going to start by deleting all the code in the code behind. So this load data can be deleted, implementation as well. I'm going to also for now delete the event handlers. The selection changed can also go, and the fake button implementation can also go. Also this observable collection, I don't need it anymore, and also this selected coffee, I don't need it anymore. So as you can see, the code behind is now really clean. There's nothing in there anymore. What I can put in here is, like I said in the slides, things like setting the focus, which only work with stuff in the view. They should still go inside of this code behind. Let's now take a look at the view. My list view is going to get its data from that observable collection on my view model. It's actually going to bind to that observable collection. So what I'm going to do here is in my list view, set the items source to a binding, and that would then bind to my coffees observable collection on my view model. Now what I also need to do is make sure that when the user clicks on an item in my list view, that the detail screen on the right, so the view detail screen, would also reflect that selected item. So what I'm going to do here is I'm going to set the selected item, and I'm going to specify here that this will also be a binding. And I'm going to bind it to something called selected coffee. So when the user now clicks on an item in my list view, what this will result in is that the selected instance will be pushed onto my view model. Of course, I need to make a small change in my view model as well to accept this selected coffee. So let's return to the view model and add the selected coffee inside of the view model. So this is my selected coffee property now. And the view model now knows what was selected. I also need to make some small changes on my view so that the detail labels also will work with that selected coffee. So for example, for this coffee ID label, I'm going to set the content to a binding. And what am I going to be binding to? To the coffee ID. And where is that coffee ID? Well, it's available on the selected coffee. .coffee ID. And I'm going to make sure that when my view model changes, that my UI will also reflect these changes. So I'm going to set the mode to one way. Note again that the label defaults to one way, so it's not really necessary, but to make things a bit clearer, I'm also adding it in this binding statement. And I need to do the same for my other labels as well. So I've pasted in some code here, and all the other labels are now bound to properties on my selected coffee. Now I can run the application at this point, but we're not going to be seeing any data in the UI. That's because we're still missing one important thing, the link between the view and the view model. That's the goal of the next demo. And there's one more thing I'm going to show you before we go back to the slides, and that's how the detail screen and its detail view model was built up. So here is the coffee detail view model, and it is actually rather simple. It has just one property called selected coffee. In the view, we'll now have our text boxes which are binding to properties on that selected coffee property of my view model. Let's return to the slides now. We have now already seen how we can write our views and our view models and how our view models can get data from the model. But we don't have a fully working application yet. There are quite a few things still missing. We're going to need to fix some of these issues. To finish this module, we'll start with a missing link. How can we make sure that the view knows or finds the view model? We are now aware that we'll need to make sure that the view needs to know what view model it will need to bind upon. In fact, there are two common ways of creating this link. The possible options are the view first approach and the view model first approach. Let's first take a look at the view first approach. In this case, we are instantiating the view first, hence name of course. The view will itself be responsible for the creation of the view model. This view model instance is then set as the data context for the view. In the sample code we see here, we are doing exactly that. The view is going to instantiate a coffee overview model and set this as the data context for the view, so the window. Now, for most scenarios, this approach will work. In fact, this approach works if for the bulk of your application, you have an easy mapping of one view to one view model. If in your application, however, you have dynamically created views, such as the new mail window in Outlook, this approach won't work. In this case, you should be looking at a view model locator, which is in fact the locator pattern. So what is this thing? The locator is a class which knows about all the view models in the application. All views know about the locator and can ask it to return a view model instance, or even create one on the fly. An alternative way of linking the view and the view model is using the view model first approach. In this case, the view model is created first and gets in an instance of the view it works with. We can then set the, let's call it, view model property from the view to the view model instance at hand. This approach is not that commonly used. Let's now make sure that our view can find its view model in the following demo. Now we're currently stuck with our application, which doesn't work at all. On one hand, we have the view models, and on the other hand, we have the views, but they don't know about each other. You have to fix this. And like I explained in the slides, there's a couple of ways of fixing this. Let's take a look. Let's start with the most basic approach, and that is setting the data context directly onto my view. So I'm going to start by declaring the view model namespace in my XAML code. So I'm going to do an XML namespace mapping, which is going to be, for example, view model. And then I'm going to point to the view models namespace in my code. And then I'm going to say controls metro window, this one, dot data context. And what is the data context going to be? It's going to be one of my view models. That will be the coffee overview view model. And if all goes well, and we run the application now, we'll see the data being displayed in the overview again. And there we go. We have on one hand the list view, which is bound to the observable collection, and on the other hand, we have these controls, which are bound to the selected coffee on my view model. Now, like I said, there are a couple of ways of doing this. This is, let's say, the most basic approach. In many applications, I use a view model locator. Let me start by removing all this, and then we'll go ahead and add a view model locator. So I'm going to add a new class here, and that's going to be my view model locator. And the view model locator is a plain class which knows about all the view models in my application. So this is the code of my view model locator. So like I said, it knows about all the view models in my application, and it has a public property for all of these so that my views can ask the view model locator, return me a particular view model. Now I have to instantiate my view model locator, and I'm going to do that again in my app XAML. Local is the application prefix, so that knows about the view model locator. And then I say x:\key, and that will be my main view model locator. And what I'm now going to do is I'm going to go back to my views. And in here, I'm going to say that the data context will be coming from a binding. To what am I binding? The source is a static resource. And which one was that? Well, that would be my main view model locator. And to what property am I binding? Well, it's going to be one of the view models. So the path will be the coffee overview view model. So I'm basically saying that this is the view model locator that I'm going to be binding to. And onto that view model locator, I ask it to return this coffee overview view model. And that will be set as the data context for my entire view. Let's run the application again. And you'll see that it keeps on working like it did before. Let's go back to the slides. With this demo finished, we have arrived at the end of this module. So far, we have a partly working application again, but there's still a lot of work to be done. Making sure that everything works will be the focus of the next module. Now, before we go there, a quick summary of what we have seen in this module. We have, of course, in this module focused on the MVVM pattern, and we have seen that it works together with data binding to display data on the views which is exposed by the view models. Because of this, we achieve a loosely coupled architecture and we succeed in having a clean separation between the logic in the view model and the view code in the view. That's it for this module. I hope to see you again in module 4. Thanks for watching.